Good evening, children. Welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Welcome to today's class. Right. So we have already discussed some points regards quadratic equation, right? Nothing but the properties of a quadratic equation. What are they? See this one. If a quadratic equation is in the form of ax square plus bx plus c equals to 0, nothing but its general form. Am I right? Now see the first one, if a and c are having the same sign, then the product of roots c by a is positive. This is the point we have discussed in our earlier classes. Okay? In a quadratic equation, ax square plus bx plus c equal to 0, where a nothing but x square constant, x square coefficient and constant term c both are same sign, then we can take that c by a also a positive. That means same sign is nothing but positive here. Whether they can be both a and c are negative, a and c are positive, we will get c by a, product of roots is positive. This is one point we discussed. And a and c are opposite sign, then product is negative. Product of roots, nothing but c by a value is negative. Second point we have discussed already. Now coming to this one, in ax square plus bx plus c quadratic equation, if you take a plus b plus c value is 0, then 1 and c by a both can be here. 1 and c by a are roots. These two are roots for the quadratic equation. That means without doing the regular process like factorization, splitting the middle term, or completing square method, or by using the quadratic formula, we can identify the factors of a quadratic equation. When a plus b plus c value equals to 0, then 1 and c by a are two roots of the quadratic equation, right? Next, what is the second condition? A plus b minus c. Am I right? No, a minus b plus c. A minus b plus c equals to 0, then minus 1 and minus c by a are roots. Okay? Here minus 1 and minus c by a are roots. Previous one, 1 comma c by a are roots of the quadratic equation. Next, if the roots of a quadratic equation are negative, then all are having the same sign. We have discussed already with an example. Okay, na? Right. So next one, if the roots are positive, that means both roots like alpha value, beta value, both are positives. Alpha comma beta are roots of quadratic equation here. If both are positive, then a and c, a comma c will have the same sign, d will be different. That means b will be different. That means x square coefficient, constant term, both will same sign. That means whether they can be positive or negative. Both are positive or both are negative, but b will be exactly opposite to the sign. That means a and c are positive, b will be negative, and a and c are negative, b will be positive. If they are positive, then b is negative. If a and c are negative, then b is positive. Okay? We have discussed in our earlier classes. Next, see here, if the roots of the general form of a quadratic equation are reciprocal to each other, reciprocal means what? Nothing but multiplicative inverse. For example, if I am writing 5 by 3, what is the reciprocal of 5 by 3? Very good, 3 by 5. That means the position of numerator and denominator will be changes. Am I right? Yeah. Simply like a statement, if A into B equals to 1, then A and B are called reciprocals to each other or multiplicative inverse of each other. Okay, na? Right. In same way, if you take 5 by 3, its reciprocal is 3 by 5. Reciprocal is 3 by 5. Now here given that roots are reciprocal to each other. That means if you take one of the root is 5 by 3, obviously second root is 3 by 5. Now if you take one of the root is alpha, what is the second root? 1 by alpha. Alpha is nothing but alpha by 1. Its reciprocal is 1 by alpha. Okay, na? So if a quadratic equation having the roots like this, roots are in the form like this, then A value is equals to C. That means x square coefficient, constant term, both will be equal. Okay. Here you should remember one point. For example, if I am taking 2x square plus 5x plus 2. Check here. X square coefficient 2, constant term also 2. That doesn't mean their the roots of the quadratic equation need not be reciprocal. If the roots are reciprocal, then definitely the x square coefficient and constant term will be equal. But for every equation, if you consider like if you take an equation blindly like this, A value and C value equal, it doesn't mean their roots are reciprocal. Okay, na? It doesn't mean their roots are reciprocal. Clear? If reciprocal, A and C values are equal, but A and C values are equal, we cannot consider the roots are reciprocals. Okay. Next. Here roots are equal in magnitude. In the magnitude means in the measure wise. That is nothing but 5 centimeters. If another one also 5, like 5 or 5, 6 or 6, same measurement. And opposite sign, that means roots are 1 minus 1 or 2 minus 2, 3 minus 3, like that. If you are having the same roots in magnitude wise, but the different in symbol wise. One is positive, second one is negative, then definitely x coefficient becomes 0. X coefficient is 0, nothing but B value. So this will happen when x plus y whole square, x minus y whole square. When you expand this value, find out the value of this, you will get the different signs, but B value becomes 0. In such a way we can take A plus B into A minus B. Simply we can take A plus B into A minus B condition. Okay, na? Simply we have to take A plus B into A minus B condition. Then magnitude wise roots are equal, but their symbols are opposite to each other. That means one is positive, another one is always negative. Clear? So mainly you should remember the conditions. What are that? A plus B plus C equals to 0. Then roots are 1 and C by A. 1 and C by A. C by A is nothing but product of roots. Most important property. And second property is A minus B plus C equals to 0. Then the roots are minus 1 and minus C by A. Okay? Right. Remember those two concepts mostly. Next, transformation of equations. Transformation of equations, this one. If alpha comma beta are the roots of a quadratic equation, the quadratic equation is given like this: f of x equals to ax square plus bx plus c equals to 0, nothing but its general form only. And then the quadratic equation whose roots, that means for this general form ax square plus bx plus c equal to 0, here roots are alpha comma beta. In case roots are 1 by alpha and 1 by beta, roots are 1 by alpha. See here, for example, I am taking 3 and 5 are 2 roots. Then what is the quadratic equation? That means alpha comma beta are roots. We are writing the quadratic equation as x square minus alpha plus beta into x minus alpha beta. This is the quadratic equation, right? So in the place of alpha, we know the root 3. In the place of beta, 5. Then how you find x square minus alpha plus beta? 3 plus 5, 8x. Minus alpha into beta, 3 5s, 15. This is we are considering as f of x. This is considering as f of x. F of x is a quadratic equation which contains the roots 3 and 5. Okay. Now 1 by 3 and 1 by 5 are roots. Then f of 1 by x is the quadratic equation for these roots. If 3 and 5 are roots, this is the quadratic equation. 1 by 3 and 1 by 5 are roots, then f of 1 by x will be the quadratic equation for the respective roots 1 by 3 and 1 by 5. Okay, na? Right. Okay, now I am going to the next one. Yeah, this is very important. Roots are negative. First root is alpha, negative alpha, negative beta. Minus alpha and minus beta are roots of f of x equal to 0 is f of minus x. Actually, alpha comma beta are roots of f of x equal to 0. In case minus alpha minus beta are roots, then its quadratic equation will be f of minus x. Same like previous one. 3 and 5 are quadratic equation. Roots of a quadratic equation, we got one equation, right? X square minus 8x plus 15 equal to 0. That is f of x. In case 1 by 3 and 1 by 5 are roots, we will get f of 1 by x. For reciprocal 1 by alpha, 1 by beta, we got 1 by x. Same way, for alpha and beta, we got f of x is equal to 0. Then minus alpha minus beta is f of minus x. Okay? Yeah. 1 by alpha, 1 by beta means quadratic equation is f of 1 by x. Minus alpha minus beta, then the quadratic equation is f of minus x. Same way, alpha plus k, here adding one constant where k is a constant. Alpha plus k comma beta plus k are roots of this f of x equal to 0. Then the equation is this, f of x minus k. Here you should identify that here plus k is given, but in the required equation we need to take x minus k. Okay. In case alpha minus k, beta minus k are roots of f of x, then required equation is f of x plus k. That means for positive symbol we need to take negative. For negative constant we have to take positive. Okay na? Here constant is what? K value, positive k. If we have extra constant values to the roots, then we have x minus k is a quadratic equation. F of x minus k is a quadratic equation. Same way, alpha minus k, beta minus k are roots. The required quadratic equation is f of x plus k. Symbols are different. But 1 by alpha, 1 by beta, f of 1 by x. Minus alpha minus beta, f of minus x. But only these two conditions we are taking in reverse order. Okay, na? That is depending on the factor theorem actually. Don't be confused. Right, same. This one we have discussed in earlier. Alpha minus k, beta minus k are roots. Then equation is f of x plus k equal to 0. Okay. Same way. Now k is a constant or multiple of something. That means alpha is multiple by k. K is a constant there. K into alpha, k into beta. Here k is multiplying But the see the equation. In required equation we are dividing. Multiply opposite symbol, dividing. That means we are transposing it. Okay. So let us find the answers for these three concepts. These concepts. Then we will go to continue the remaining concepts. Okay. Once revise. Yeah. So mainly you remember this. If a plus b plus c equals to 0, then what are the roots? 1 and c by a. 1 and c by a. A minus b plus c equals to 0, then minus 1 and minus c by a. And transformations, 1 by alpha, 1 by beta are roots. Then required quadratic equation is f of 1 by x. Same way, minus alpha, minus beta are roots. F of minus x equals to 0. Then alpha plus k, beta plus k are roots. Then f of x minus k. Here positive means negative we should take. Such a way, alpha minus k, beta minus k are roots. Then the quadratic equation is f of x plus k equal to 0. Same way, k into alpha, k into beta are roots. Then f of x by k is our required equation. Clear? Yeah. Conceptual based questions here. If 1 is the root of ax square plus bx plus c equals to 0, when we get 1 is the root, 1 c by a are roots when the condition is a plus b plus c equal to 0. A plus b plus c equals to 0. So our option is 2. Okay, na? Or else see how I am doing this. How the condition is satisfying like this. Actually, what is root of a quadratic equation? We can call root of a quadratic equation or 0 of a quadratic equation. That means for some value, when the quadratic equation becomes 0, that value is called root of the quadratic equation. For example, I am substituting 5 in a certain quadratic equation. The entire equation value becomes 0. We can call that the 5 is the root of the quadratic equation. Same way, here given that 5 is root of quadratic equation, that means f of 5 equals to 0, where f of x is quadratic equation, no? F of 5 equals to 0. That means when you substitute, it should be equals to 0. Same way here clearly given 1 is root. 1 is root means we need to substitute here. That means in the place of x, we have to substitute 1. A into 1 square. That means in the place of x square. In the place of x, 1 square. B into x. That means b into 1 plus c equals to 0. 1 square value 1. A into 1 a only plus b into 1 b plus c equal to 0. If 1 is the root, when you substitute in the given quadratic equation, we will get the condition like this. In the same way, in the question is given, the condition is given, if a plus b plus c equals to 0, 1 is the root, obviously. Okay? Right. Second one, what is the second condition? A minus b plus c equal to 0. Now tell me that what are the roots? Very good. What are the roots? Minus 1 and minus c by a. Very good. Your roots are minus 1 minus c by a. So in your option, you have to find. That means both together will give, no problem. Otherwise, minus 1 give means you can keep minus 1, or minus c by a means you can keep minus c by a. Anything, your choice. I think will be given like this one. Minus 1 comma minus c by a will be given. Yeah. See here, alpha, beta are roots of this quadratic equation. the quadratic equation is given. I am writing f of x equal to x square minus 2x plus 3 equal to 0. This is the given quadratic equation. And then the equation whose roots are alpha minus 3, beta minus 3. So it is looking like alpha minus k, beta minus k. In earlier we have discussed about these conditions. If alpha minus k, beta minus k are roots of the quadratic equation, then the required equation is f of x plus k. F of x plus k equal to 0. Am I right? So here, what will be the required equation? Very good. F of x plus 3 equal to 0. F of x plus 3 equal to 0. This is our required equation. Okay, na? From the conditions we learned. Here k value is nothing but 3. X plus 3. But we have to find the quadratic equation now. That means, see here, in the place of x, what is being here? X plus 3. In the place of x, we can have x plus 3. That means, whenever you see the quadratic equation with the term or with the variable x, we have to substitute x plus 3. Now check, what is f of x? X square. That means f of x plus 3 is nothing but in the place of x square means here you should write x plus 3 whole square. Only x, that's why we got x square. But here x plus 3, in the place of x we have to substitute x plus 3 whole square. Now minus 2x. In the place of x we should write x plus 3. 2x means 2 into x. Here also 2 into x plus 3. Plus 3 is equal to 0. Constant now. Next, see that first one, x plus 3 whole square. X plus 3 whole square. That is nothing but in the form of one of the algebraic identity, a plus b whole square formula. What is a plus b whole square formula, children? Very good. A square plus 2ab plus b square, or a square plus b square plus 2ab, anything same. Now I am expanding like that. Here what is a? A means x, b means 3. A plus b whole square, expansion a square. So x square plus b square 3 square plus 2ab, 2 into x into 3. I am just expanding the first term because it is looking like a plus b whole square. So a square plus b square plus 2ab. Next, this one, minus 2 into x plus 3. The bracket 2 terms should be multiplied with minus 2. So minus 2 into x, minus 2x, minus 2 into 3, minus 6. Last constant term plus 3 as it is, equal to 0. Now check, x square is as it is. 3 square value, 3 square is nothing but 3 into 3, 3 3s are 9, plus 2 into 3, 6, 6 into x, 6x, minus 2x, minus 6 plus 3 equal to 0. Simplify, that means add or subtract the like terms. X square is only one single term, we cannot change. Now check the text terms, plus 6x minus 2x. 6x minus 2x is 4x. 6 is bigger than 2. So 6 symbol positive, you will get 4x as positive. Now numbers, 9. 9 minus 6, 3. 9 minus 6, 3. 3 plus 3, 6. So what is our required quadratic equation? X square plus 4x plus 6 equals to 0. That is nothing but option 2. X square plus 4x plus 6 equal to 0. Okay, no? Like this we should write. It is an example for that. alpha minus k, beta minus k are roots. F of x plus k, how we are writing means, whenever you see the x value, in the place of x value, we should substitute x plus k. Here we got x plus 3, that means we have to substitute x plus 3 in the place of x. After simplifying, we will get the quadratic equation x square plus 4x plus 6 equals to 0. Please note it, children. Right. So let us go to the next problem. Yeah. So this is x square, children. If alpha, beta are the roots of x square minus 2x plus 3 equal to 0. So let me take the given quadratic equation f of x equal to x square minus 2x plus 3 equal to 0. This is the quadratic equation. Then the equation whose roots are alpha plus 2, beta plus 2. Yeah, did you get that? What will be the required quadratic equation? If f of x is x square minus 2x plus 3 is equal to 0, then what is the required quadratic equation, children? F of x minus k. What is the k value here? 2. That means f of x minus 2 is our required quadratic equation. Okay, na? Yeah, here I have written, if alpha minus k, beta minus k are roots, or alpha comma beta are roots of f of x, then alpha minus k, beta minus k are roots of f of x plus k. Same condition we are applying here. Yeah, our required equation, our required quadratic equation is f of x minus 2, where 2 is the constant. Alpha plus k, beta plus k, nothing but alpha plus 2, beta plus 2, f of x minus 2, our required answer. Now I am going to substitute here, in the place of x, what to write? X minus 2. Here only I am substituting x minus 2 whole square minus 2 into x minus 2 plus 3. Constant term is not affected. Wherever you can see the variable term, in the place of variable only, we need to substitute x minus 2. Okay, in the place of x, we need to substitute x minus 2. Right. Which formula it is appearing like? First one, this one. Yeah, it is looking like a minus b whole square formula. Yeah, just tell me that a minus b whole square formula, children. Yeah, a square plus b square minus 2ab, or a square minus 2ab plus b square, anything is same. Yeah, according to you, I am writing here a minus b whole square formula is nothing but a square plus b square minus 2ab, am I right? Now x minus 2 whole square formula, x minus 2 whole square I can write as x minus 2 means, yeah, first term, x square plus 2 square minus 2ab, that means 2 into x into b value is 2. A square plus b square minus 2ab. Here minus 2 we have to multiply with minus 2. Minus 2 into x minus 2x, and minus or minus plus 2 2s are 4 plus 3. Right, expand this, x square, 2 square value 4 minus 2 2s 4, 4 into x 4x. Next minus 2x, 4 plus 3 7 I can write. 4 plus 3 7. Next, x square term only single term I can write directly as it is. Now x terms, minus 4x minus 2x, both are negatives, we can add with negative symbol. So minus 4x minus 2x is minus 6x. Now remaining numbers 4 and 7, 4 plus 7 is 11. Therefore, our required equation is x square minus 6x plus 11 equal to 0. That means equation number 1. X square minus 6x plus 11 equals to 0. Okay, no? Yeah, please check. And once revise the concept. Again, you go through the concept today. We will discuss the remaining topics, related topics regarding the transformation of quadratic equations in our next class. Okay, na? Yeah, just revise these concepts, very important. See here, today what I have learned here. Yeah, here onwards, transformation of equations. Alpha, beta are roots of the quadratic equation. Then 1 by alpha, 1 by beta are roots of the quadratic equation f of 1 by x. F of 1 by x. Same way, alpha, beta are roots of f of x, the quadratic equation general form. Then minus alpha, minus beta are roots of f of minus x. Next, alpha plus k, beta plus k are roots of alpha, beta are roots of f of x. Then alpha plus k, beta plus k are roots of f of x minus k. Positive means we have to take negative. For negative value, we should take positive. Same way, alpha minus k, beta minus k are roots of f of x plus k equal to 0. And k into alpha, k into beta. That means alpha, beta are roots of f of x. Then k into alpha and k into beta are roots of f of x by a equal to 0. And based on this, we did the problems. Yeah, first problem based on conditions, and this is check. This is the last problem we have discussed. Clear? Yeah. That's it for today, children. Thank you one and all. Have a nice day. See you in next class.